Okay, guys, so again, by substitution. In this case, both of these are in beautiful y equals mx plus b form for your linear, and then standard form, y equals standard form for your quadratic. So probably, if left to my own devices, I would graph them in Desmos. But we're going to copy these down as substitution just for practice of solving equations. So x minus 3 is going to equal x squared minus 12x plus 27. Excuse me. So we're going to try to get everything across on one side so the quadratic is in standard form. We're going to leave the x squared on the right side because we want it to stay positive. And if I started moving all that over, it would become negative. So I'm going to subtract x, and I'm going to subtract x with its like term, and I'm going to add 3 and add 3 with its like term to make these guys disappear. So now we have 0 equals x squared minus 13x plus 30. Now, we need to know to check, is there GCF? No need, because there's a 1 in the front, so that won't work. But are there multiples of 30 that will add or subtract to give me 13 and actually a negative 13 while having a positive 30? So I have 1 and 30, 2 and 15, 3 and 10, and that bad boy looks pretty good to me. So 3 and 10. To give me a positive 30, they could both be negative and multiply and give me a positive 30. Add them together and we get that negative 13. So we are going to go with x minus 3, x minus 10 equals 0. So these are the factors, but our goal is to solve. So at that point, we're going to set them both equal to 0. Solve for x. So x is going to be a positive 3 and x is going to be a positive 10. Now, we have to keep going because remember, the solution to a system is a coordinate. It's a place. It's where on the graph the two functions intersect. So I'm going to take my x equals 3 and plug it in the first one. So 3 squared minus 12 times 3 plus 27. 9 minus 36 plus 27. Then we're going to combine those. So 9 minus 36 plus 27 is going to give us 0. We can check it. So 3 minus 3 is also 0. So when x is 3, y is going to be 0 for this system. Then for 10, so 10 squared minus 12 times 10 plus 27. So 100 minus 120 plus 27 is going to give us a positive 7. And then 10 in our second one, 10 minus 3 also gives us a positive 7. So when x is 10, y is 7. And again, you can do this in Desmos, and that's where you're going to type in the two equations and see them graphed if you do not have to do it by substitution. Right now, my suggestion is this is super easy, so practice the substitution part, but know this is your backup plan to check it, because I know 3 zeros right and 10 sevens right. So now I know that I did my math correct. All right, so example number 2. I'm going to again get this into y equals form because, as I said yesterday, that's my favorite. It's the easiest because then I can graph them if I want to double check them and all the things pan out for me. So I'm going to move my x over. So y equals 16 minus x. So the bottom is now going to be set equal to the top. So 16, and I'll put minus 1x. That way I don't lose it. Equals x squared minus 7x minus 11. And again, we need to get it in the standard form. So everything together, we want that x squared to stay positive. So I'm going to subtract 16. And I'm going to add 1x. And you put it with this like term as it crosses over that equal marks. So it's going to be 0 equals x squared minus 6x minus 27. Now, we can sit here and try to factor it, or just for a different example and for more practice in your notes, we're going to do negative b plus or minus square root b squared minus 4ac all over 2a. So that's your quadratic formula, right? So negative b, so I've got a negative 6 for my b spot. So b is going to be, the negative b in the front is going to be a positive 6 because that negative makes it positive. So plus minus negative 6 squared minus 4 times 1 times a negative 27. And then we're going to put that all over 2 times 1. So 6 squared is going to give me 36. So I have negative 6. I'm sorry, the 6 on the outside stays positive. So negative 6 squared is 36. So 6 plus or minus. And again, as I said yesterday, I'm writing out more than you have to. Minus 4 times 1 is negative 4. And negative 4 times a negative 27 is going to give me a positive 108. And 2 times 1 is 2. So we're going to add that 36, and that gives me 144. So 6 plus or minus the square root of 144, all divided by 2. And we know that the square root of 144 is 12. So we're going to split this into two equations. 6 plus 12 divided by 2, 6 minus 12 divided by 2. So 6 plus is going to give me 18 divided by 2, which is going to give me 9. And then 6 minus is a negative 6 divided by 2, which is going to be a negative 3. So 9 and negative 3 are the two we need to plug in to see what our y values are. So 9 and negative 3. So 9 squared minus 7 times 9 minus 11. So that's 81 minus 63 minus 11. And 81 minus 63 minus 11 gives us 7. And then for the second one, 9 plus y equals 16. Subtract 9 from both sides, and y again equals 7. So when x is 9, y will be 7. So that's one place that it's going to overlap. And then we're going to check our negative 3. So negative 3 squared. Be careful if you're putting this into a TI-83 or one of those calculators from school, because if you don't use your parentheses, it won't do the operation correct. Because negative 3 times negative 3, if I ask you, you know is a positive 9. So 21 minus 11, which is going to give me 19. And then negative 3 plus y equals 16. I'm going to add 3, and y is going to equal 19. So when x is negative 3, in both equations, y is going to equal 19. So that's our example number 2. And one more. This one's a good call out, because this is going to be one where we're going to mess up. A lot of people are going to mess up. That y right here is negative. So we want to make sure we don't forget about that negative y, because that's a problem. You can't say that negative y is equal to positive y. So it's not quite as easy to move around as the ones prior. So at that rate, you can do it a couple different ways. You can move the 2x and divide everything by a negative 1, because remember, this is a 1. So 12 equals 2x minus 1y. Subtract 2x from both sides. These are not like terms, so we just end up with 12 minus 2x equals a negative 1y. Divide by negative 1. So we end up with a positive 2x and a negative 12 equal y. Or you could move the y and then move the 12. So what that would look like, depending on which way makes more sense to you, and you know your positive, negative mistakes. We've been in school long enough doing this that you know where you mess up. So figure out the way that works best for you. So I'm going to move my y. And then I have 12 plus y equals 2x. And then I'm going to move my 12. And y is going to equal 2x minus 12. Same thing, same math. It's just whichever one makes sense to you. So now that I have y equals and y equals, I can rock and roll for solving. Get rid of this. So we're going to set them equal to each other. So y equals, oops, sorry, no need for the y part. Getting excited. So negative 2x squared plus 8x minus 4 equals 2x minus 12. Again, great divide. Move the things over. I would like this to be positive, so I'm going to move everything to the right. Otherwise, you're going to divide everything by a negative 1 to make it better, or negative 2, all the things. So I'm going to add 2x squared, add 2x squared. I'm going to subtract 8x, and I'm going to add 4, add 4. So then now I'm just combining like terms on this side. And you have to do the opposite. Otherwise, they won't undo on the side that we need to be a 0. So now I have a 2x squared, and it's positive, so that's beautiful. So we took care of that guy. I have a positive 2x and a negative 8x. That's going to be a negative 6x. Took care of that guy. And then negative 12 and a positive 4. So we're going to have a negative 8. Now, first thing you want to check always is there a GCF? And in this case, there is 2. And if you would, I would challenge you to pause the video and see if you can factor this correctly yourself. But we're looking for negative 4. Multiples of negative 4. That will give us a negative 3. So 1 and 4, 2 and 2. 2 and 2 are off the gamut. That won't work. That won't ever give us negative 3, or a positive 3 for that matter. So 1 times 4 will give me 4, and 4 and minus 1 will give me 3. I need a negative 3 and a negative 4. So one of these two numbers needs to be negative. 4 is going to be best because our b is negative, so the largest multiple needs to be negative. So x minus 4, x plus 1. And that, with the 2 on the outside, is the factored form, but we need to solve because we want to know what values of x we're working to see to plug in to get our y. So add 4. So x is 4, subtract 1, subtract 1. So we're checking 4 and negative 1. So in our first equation, negative 2 times 4 squared plus 8 times 4 minus 4. 4 squared is 16, so negative 2 times 16, and I'm just writing out all the math so you know where these numbers are coming from. And negative 2 times 16 is going to give you a negative 32 plus a positive 32 minus 4. These guys cancel each other out, so I end up with a negative 4. And you want to check the other one. So 12 equals 2 times 4 minus y. So 12 equals 8 minus y. We're going to subtract 8 from both sides. Be careful about that minus y. I have a positive 4 equals negative y, but that's not the same as our other one. So we're going, because that's not a y by itself, we're divided by negative 1, which means y equals negative 4. So again, when x is 4, y will be a negative 4. And then we can go and check. Pause the video and see if you can check the second one. See if you can check with our negative 1. And then come back and watch it and see if you got all your math right. Because the more you practice, whenever you're going to make a mistake, you'll see your pattern and you'll be able to outsmart yourself. So negative 2, negative 1 squared plus 8 times a negative 1 minus 4. Negative 1 squared is 1 times a negative 2 minus 8 minus 4. Negative 2 minus 8 minus 4 is going to give me a negative 14 because that's 10 and 4, and they're all negatives. Plug our negative 1 into our next equation. So 12 equals 2 times a negative 1 equals a negative y. I'm sorry, minus y. Oops, not equals, sorry. Getting real excited. We definitely never have two equals. So that's 12 equals a negative 2 minus y. Add 2 over, so that's 14 equals a negative y. Be careful. Divide by negative 1. And that is also negative 14. So in that case, when x is negative 1, our y is negative 14. And those should be your two solutions to this system. All right, great job, guys. Hang in there.